So continuing on from our previous video, I'm going to open up BP terminal. I'm going to drag the execution pin of the begin play node and search for enable input. Connect the get player controller node to it. Now using the enable input node, we can actually control our pieces, which is an actor, using keyboard input. So at the start of our game, we can actually control our pieces thanks to this node over here. After this, we are going to make the logic for moving our pieces using the VASD keys. So I'm going to search for the keyboard event nodes for V, A, S and D keys. Then I'm going to duplicate the nodes. And after that, I'm going to click on this icon over here and click on a key to assign it to the keyboard event. Do the same thing for the rest of the keyboard events. So we have the VASD keys. To actually change our piece's location, I'm going to use the set actor location node and then connect the pressed execution pin to the set actor location. After that, I'm going to copy all these nodes and paste these nodes for each of the keyboard event nodes over here. Then for each of these events, you need to change this node and its connections based on which direction you want this key to move your piece. So just pause the video and recreate these nodes over here. By the way, if you don't know how to create this node over here, just right click over here and then search for subtract and you'll get this node over here. So to explain how this node over here works, when we press any of these keys, we are just moving our pieces by 100 units, as you can see by the value over here, through the X or Y axis. When I want to move my piece forward, I need to add 100 in the y-axis, and subsequently when I want to move my piece backwards, I need to subtract 100 in the y-axis. Similarly, for the x-axis, our left and right movement is controlled by adding or subtracting 100 in the x-axis. Now this arrangement of nodes, right, so this adding or subtracting of 100 might be different for you depending on how you positioned your camera. So if I were to run this game, right now in this angle that my camera is at, pressing the W key moves my piece forward, pressing the S key moves my piece backwards, and pressing the A key moves it towards the left and the D key towards the right. But this controls could be different for you if your camera is positioned in a different angle. Alright, so these values over here might need to be tweaked based on how you positioned your camera. Also, currently, I can't move my camera around anymore. Instead, it's my piece that's actually moving around. And the reason for that is because I have transferred the control of a player controller onto a terminal piece using that enable input node that we have created before. So I can't change this awkward angle that my camera is at. So instead, I'm going to click on this icon over here and search for player start and drag this over here. So a player start is basically the location where our player will spawn at when our game starts. And in case you don't know, the player in our game is currently our camera. So we can kind of change the camera angle by changing the spawn location of our camera. And then while changing the location of our player start, make sure this blue icon over here, this light blue arrow icon over here, this represents the direction that our player will be looking at when it spawns in our level. And right now, it's facing the other direction. So if I were to spawn, you can see it's looking at a different direction. So to change it, While the player start is selected, navigate to rotation and change this value over here. So I'm going to give it a 90. I'm also going to change the position like this. So it's kind of facing towards the playfield. And if I were to run this game now, it's a bit more better. After that, I'm going to quickly add a comment to our logic over here. So for rotating our pieces, I have created these three keyboard events, the G, H and J keyboard events that will control the rotation of our pieces in the y-axis, the x-axis and the z-axis. So you can just recreate the nodes as you see over here. And I will demonstrate why we're using the add actor will rotation over here over the set actor rotation node when we run our game. So if I were to compile this and run the game again, clicking on the G key rotates our pieces in the y-axis, the H key on the x-axis and the J key on the z-axis. So if I were to just rotate my piece once and then rotate it again in another axis, it will rotate while preserving the rotation. This is really important to make the control of the Tetris pieces feel more like 3D. Most Tetris games have the same mechanic in them, and it also allows a greater degree of freedom for the players to choose from. And that's also the reason why we're using the add actor will rotation node, since it is adding our rotations together to come up with the next rotation for our piece. If we were to use the set actor rotation node instead, it won't be preserving the rotation like before. So yeah, that's one of the main reasons why I'm using the set actor will rotation node. After this, we're going to add the logic for detecting collisions, because currently our pieces are not detecting the boundary. So back in here, I'm going to create a new function and call it does piece fit. And I'm also going to create a local variable by clicking on the plus icon over here under local variables and call it local can move. And I'm going to set the default value of local can move to true. After that, just follow along and recreate the nodes. And I also want to mention this, make sure that you're searching for the get components class and not the get component class. Right, so these two nodes are different. So what these nodes does is that, first of all, we assume that whenever we want to move our piece, we can actually fit there. Hence why can move is true by default. Then we get all the static mesh components in our piece, and for each of them, we're going to run a line trace starting from its location and ending in a direction. And this direction is determined by which key we press, which I will be adding the logic for that later on. So if our line trace hits anything, our can move over here will be set to false. But if our line trace hasn't hit anything, after running through all of our static meshes, then our can move variable will remain true and our function will return that value. And this means our piece does fit in the direction it wants to move. Right, so That's a simple explanation on how this code works. So anyways, coming back to our event graph, now we need to quickly add the logic for setting up our direction and collision for each of our keys. So I have added the direction and the collision detection function for each of our keys over here. So make sure to copy these directions for each of these keys. And these directions are based on the movement of the piece. So if you have changed any of these values over here, then you might need to adjust these directions accordingly. So now I'm going to just run the game so we can actually see what's happening. And if I were to move the piece towards the border, you can see it's not moving past it. So if I were to enable the visibility of these borders for just demonstration. Alright, so now if I were to try moving the piece towards here, you can see it's not moving past the borders. Alright, so collision detection system. So I made a small mistake when positioning the target point. So if I were to check its location, currently it's 550 in the X and Y axis, and that's the problem. You see, we are faking our Tetris grid by placing everything exactly 100 units away from each other. And since our target point, which is basically our tetromino spawn point, isn't positioned 100 units away, it's spawning our pieces in between the grids, resulting in that weird facing we saw before. So the fix for this is really simple. We just change the position of this target point to something in the hundreds. So maybe 500 or 600 in the X and Y axis. So I'm just going to give 600 in the X and Y axis. This way they are mostly in the center of our playfield. I also made a small mistake in the directions of the V and S key. So I just flipped the positive and negative values around. And we're just going to run our game. And this time, you can see if I were to move my piece towards here, it's not facing through our borders. So if I were to just delete this player start just temporarily and then run our game again, so I can actually see our piece moving through this direction, you can see it's not facing through our border anymore. To make this even more clearer, I can go to the does piece fit function over here, and in the multi-line tracer by channel, I'm going to change the draw debug type to something like persistent. Compile this, and if I were to run this, you can see it's leaving a trace behind. So these red lines represent the line trace. You can see our line trace actually hit the border, resulting in our function returning false and not allowing our piece to move further. And to make this extra clear, I'm going to run this game and change the view to wireframe, and now we can actually see our line traces more clearly. you can see those green lines that came when our line trace hit the border. So that's the line trace actually detecting that it hit something and hence returning a false. Currently, our function does not take into account for collision when rotating. So there's a simple fix for that. So I'm just going to quickly add the collision detection for our rotation logic over here. So what these nodes do is that we first store our current rotation into a variable called before rotation, and then we rotate our piece just like before. After that, we run our does piece fit function to see if our now rotated piece is colliding on something or not. After rotating our piece, we want a small value in our direction, since a 0 over here means our line trace would not be able to collide with anything. So if our function returns true, our rotation will remain as it is, but if it is colliding with something, then we basically undo our rotation with this node over here, using the previous rotation that we saved in our before rotation variable over here. So it appears like we haven't even rotated our piece. So yeah, that's really about it. If I were to run my game, currently I can rotate my piece, but if I were to move my piece over here, I can't rotate my piece anymore because our piece is getting blocked by our boundary, right? So you can't really see our piece undoing its rotation when we try to rotate our piece into an area where it might collide with something. And I guess that's enough for this video. In the next part, we will look into moving our pieces down, setting up the tick system, spawning new pieces and more. So thanks a lot for watching, and once again, sorry for the delay. See you in the next video. Bye.